Hey guys, it's Mr. Bosher, and in today's lessons we're going to go over our second type of transformation, which is reflections. Now, the easiest way to think about a reflection is that it's going to act kind of like a mirror, and when you use mirrors, what they do is they flip the image that we already have. So what we're going to see in this problem is that we're going to take this triangle and we're going to try to flip it in some way. Now, the good news about reflections is there's only two types of reflections. We have reflections over the y-axis, which is what our problem has for us here. And then we have reflections over the x-axis. So, if they give us a reflection over the x-axis, we should expect to get the formula xy, so whatever your starting coordinate point is, should be changed so that the x's switch signs and the y's stay the same. Okay, now I wrote this as negative x. This does not mean that your final answer for x is always negative. This just means that we're going to change the sign of whatever our original was. So if it was positive, it goes negative. But if our start value is negative, then this turns into positive. Okay? So think of that more as like changing the sign rather than it has to be negative. Then, pretty similar to our y-axis reflection, when they ever say reflect over the x-axis, we're going to say, okay, well, I start with a normal point, x and y, and I'm going to change that by keeping x is the same, but my y values are going to change sign. So we're going to write negative y. And again, this does not mean the final answer is negative. It just means you're going to change the sign. So positives go negative and negatives go positive. So let's see how this actually works out. Okay, like why do these formulas work? Well, I'll show you over here. So this problem says reflected over the y-axis. What that means is you imagine you're placing a mirror at the y-axis, and we want to see how that shape would look on the other side of that mirror. Now, some of you could probably do this visually and just like be like, oh, the point should be here, and you can just see that, and that's great. If you can do that, awesome. If you're having trouble getting seeing that, then that's where the formulas come in. And plus, there's some questions that kind of just like ask you to remember the formulas, so it doesn't hurt to practice them. So that's what I'm going to show you here in case you can't just see how to do it intuitively like that. So, how do you do it if you can't just see it from the beginning? Well, you go one coordinate point at a time. So if I look at this coordinate point right here, and I'll zoom in, this coordinate point starts off as -5, -4. Okay? If I use my formula for reflecting over the y-axis, it says keep the y the same, but the x should change its sign. So now instead of -5, this should turn into +5, and my y value is still -4. So I get this coordinate point right here at 5, -4. So let's see if I can fit that. 5, -4, right there. So I switched the x, the sign on the x, and I kept the y the same. And then I just continue it with the rest of them. So I go to this coordinate point. This coordinate point says -1 and -3. Well, x's need to go positive, right? It needs to change its sign, so I get to 1. And I keep the y value the same at -3. So I get the point 1, -3. Then you do it with the last coordinate point. So I have -2, -8. Then the x value needs to go to positive because it changes its sign, so it goes to 2. Y value stays the same at -8. So we get our coordinate point here at 2, -8. And then you would just connect them, and that's how you get your reflection. Okay, so it's really as simple as that. I'm going to do one more problem where you don't get a picture, which is where you kind of have to use the formulas. But here, since you're just drawing the picture, you don't really need the formulas if you can just kind of see what's happening. But it doesn't hurt to practice them. Okay, so let's try a different one. So let me leave this one. And let's go to this one over here. So this is your other problem type. This one takes your graph away. So the idea of like drawing the mirror on the y-axis, or if they say x-axis, drawing it on there instead and just seeing it. Can't really do here. So how do we go about it? Well, the first thing you need to do is you need to see what reflection they want. Here they said reflect over the x-axis. Remember, on the previous problem, I told you that if we reflect over the x-axis, we know the formula says that you're going to change the x's and keep your y's the same. Or sorry, that's not right. Got myself backwards here. So you can see how it's a little difficult to do these formulas if you don't think about them too much. X stays the same, y changes. Yeah. Okay, so see, even I need to still practice mine. But once you have those formulas down, we know that, okay, that's what we should expect if it says reflect over the x-axis. My x values will not be changed, it's the y's that change. So basically, whatever axis they say, that's the value you don't touch. So x-axis means that we keep x the same. So we go point by point. So I'll give them each a different color. We have A, we have B, and we have C. So if I'm working on point A, I could say, well, the beginning point was 6 and 10. If I follow my formula, it says keep the first thing, the x value, the same. So I get 6. And it says take the y value and change its sign. So I get -10. There you go. And that's the whole problem for how to get our new A value. B was 9 and -4. Well, by our formula, it says keep x the same, so we keep that as 9, and then change the sign of the y, so now it's +4. And then lastly, for C, we had -2 and 11. Well, our formula says keep x the same, so it's still -2, and change the sign of the y, so -11. And that's it. So, first half is graphing. You can either use the formulas still and go one point at a time and then draw the shape, or you can place your imaginary mirror and do the points that way, whichever is easiest to you. Second half, no picture, so you're really going to have to know these formulas and try to start practicing that. Remember, whatever axis they say is the same value that stays the same. So if they say x-axis, the x's don't change, the y's need to change sign. If they say y-axis, then the y's don't change, and the x have to change sign. Okay? So try to use that trick, try to get that into your memory so that if they ask it on a test, or if I ask it on a test, you're like, okay, I know my reflection formulas, and we're good to go. All right, if you guys have any questions, send me them through Canvas. Hope you guys have a great day, and good luck on the assignment.